Okay, welcome back. So in the last video, we resolved a DNS request, which helped us in our quest, to answer the overall question, what happens when I type www.google.com into my browser's URL bar? DNS is the part of this that maps google.com to an IP address. And now we have an IP address, and the next steps that we're going to take are all about setting up an HTTP request, setting up and fulfilling an HTTP request. So we're finally going to be able to actually communicate with Google's server using the IP address that we got in the last step via DNS, and we're going to use that IP address to send an HTTP request to Google's server. But I wanted to do this video, which is a little bit of an aside, to bring back one of the core concepts of networking, which is the concept of the layers of the network. Okay, so if you remember in the first video, I talked about 5 critical important layers of the networking stack, and the top layer, layer 5 here, is the application layer. And DNS and HTTP are both application layer protocols. These are services that we want to use directly, to either change a URL, a name, into an IP address, or HTTP, which is a pretty flexible protocol, but used for data transfer, and it can transfer all kinds of data, including, critically for us, HTML data, images, and a bunch more, JavaScript, CSS. All of these web assets that are important to, actually viewing the google.com website are going to be served over HTTP. But these are both application layer protocols, and one of the reasons I wanted to do this aside is because DNS and HTTP, although they are application layer protocols, they specify the underlying, let's use another color, transport layer protocols to use. And DNS uses a transport layer called UDP, the user datagram protocol. And HTTP uses a different protocol called TCP, the transfer control protocol. Okay, and these two transport layer protocols behave very differently. They do different things, and I should say that DNS can be served over TCP, and there's even standards to serve DNS packets over HTTP. That's a little bit of an aside, and in the further resources section, I'll have some links that you can look at to see those protocols. But by default, DNS uses a protocol called UDP, and HTTP uses a protocol called TCP. But both of these use a network layer protocol that we know and love. They both rely on IP. Okay, so in this video I want to describe a little bit about, more in detail what it means when we say this application layer protocol uses this transport layer protocol, which uses this network layer protocol, and describe some of the differences between UDP and TCP. These are the two most popular transport layer protocols that are used in conjunction with the network layer protocol, the IP, Internet Protocol. Okay? Okay, so with this idea in mind that we're going to examine the layers of the network, let's start with a DNS request and kind of try and understand what this really means. When we make a DNS request, our computer starts by making a packet of data, a group of data, in the language of the DNS protocol. So DNS specifies a particular data format that it expects data coming in. So if you're a DNS server, or you're a DNS resolver, or you're, a computer with a DNS query to ask, you follow the rules specified by DNS and create a DNS query. Okay, so this is all of the information that's just relevant to the DNS applications. It could be the A record, or it could be the response to your A record query, which would also contain an A record, or it could be an NS record, or whatever. But it's in a format that DNS has specified, and I'll link the RFCs, some of them for DNS, so you can see that if you'd like. Then, once we've done everything that DNS cares about, we take that DNS query and we wrap it in a UDP format. Okay, so this DNS query becomes embedded within a UDP datagram, and the UDP datagram then becomes embedded itself in an IP packet. Okay, so at all of these levels, at each of these levels, there's a binary data format specified by the protocols themselves that allows, us to separate the concerns of what DNS needs to know versus what the two computers communicating, not the DNS applications themselves, but the transport layer protocols need to know, versus IP, which every router on the path from us to our DNS resolver, some information that those routers need to know in order to, appropriately forward the packet to its final destination. So when we actually finally send out a piece of data from our computer, it's wrapped in, an application layer. That's the main packet of data that matters to the two applications on either side of the connection. Transport layer, which also matters only to the two applications on either side of our connection. And then an IP packet, which matters to every network layer device, meaning every router in between us and Google will rely on the IP information, which includes, say your IP address, the source and destination IP addresses. And then finally, at every layer, quickly just erase this, we also have to include link layer information. And this link layer information is point-to-point information, and it'll be replaced wholesale as it travels through the network. So let's see what I mean here. Let's go back to our little diagram where I'm sitting on my computer here, and I'm connected to a little router, and that router is connected to a modem, and that modem is connected to a little box on a telephone wire pole, and that's connected into Comcast's main network where it first touches a router, and maybe it goes to another router here. And then it's going to get forwarded into another network, so on and so on through the internet, which is this little cloud, and then out eventually at Google's server. Okay, so here's, an abbreviated topology of where our data is going to go. So I create all 5 layers here. I create, the DNS packet, and it gets wrapped in a transport, and it gets wrapped in a network, and that gets wrapped in a link. Okay, and this link layer is specific to however my computer is connected to this router. So this link layer is going to be a Wi-Fi packet. And once it gets here, these two are connected via Ethernet. So this Wi-Fi layer, this link layer, is going to be replaced entirely. And this thing is going to communicate to this router is going to communicate with this modem over Ethernet. So it's going to have to do a new Ethernet packet, replacing that old Wi-Fi packet. So this thing looks at the link layer, and it also looks at the IP layer, looks at the network layer, because it has to say, hey, I'm a router, I need to know which IP address I'm going to end up forwarding this piece of data to. So it looks at the IP address in here and says, oh, I'm supposed to forward it to the modem based on its forwarding table, based on the rules of BGP and our routing protocols from a previous video. And then this thing's going to talk to this little box over a new link layer protocol, depending on what this connection is, if it's fiber optic or if it's a cable wire or if it's something else. It'll be a new link layer protocol, and that'll happen every single time. And all of the layer 3 devices, all of their routers, are going to look at and potentially change a little bit of this IP packet. Because there's some data in here, for example, like the time to live field, or in IPv6 it's called the hop limit, that specifies how many times I can forward an IP packet before I'm supposed to just discard it. So at every router, we'll look at this IP layer and change it a little bit. But crucially, when we're thinking about just the application and transport layer, only me and my end destination, the DNS server in this case, end up examining the UDP layer and the DNS layer, the transport and application layers, so that they can communicate with each other. You know, the DNS resolver obviously has to read the DNS query that I sent in order to determine what question I'm asking. And here at the transport layer, with UDP there's not very much to do, but as we'll see in TCP, there's a lot of different things that could happen, but only the two endpoints read the transport and application layer, whereas the link layer is going to get replaced wholesale every single time it gets forwarded to another new device, and the network layer will change slightly at each layer 3 device. So that means every router.